Mengumumkan ketibaan yang berbahagia, Dato' Profesor Dr. Ahmad Farhan Muhammad Sadullah, Naib Chancellor Universiti Putra Malaysia, diiringi Ahli Pengurusan Fakulti Kejuruteraan. Mohon kerjasama semua hadirin untuk kekal berdiri untuk sesi bergambar. Nyanyian lagu Negaraku dan Putra Gemilang. dipersilakan duduk. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang berbahagia, Datuk Profesor Dr. Ahmad Farhan Muhammad Sadullah, Naib Chancellor Universiti Putra Malaysia. Yang berbahagia, Profesor Insinyur Dr. Muhammad Hairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan Universiti Putra Malaysia. Yang berbahagia, Profesor Insinyur Dr. Aduwati Sali, Profesor di Jabatan Kejuruteraan Sistem Komputer dan Komunikasi, Fakulti Kejuruteraan yang akan menyampaikan syarahan inaugural pada pagi ini. Ahli keluarga, yang berbahagia Profesor Insinyur Dr. Aduwati Sali, pegawai-pegawai kanan universiti, ahli-ahli Fakulti Kejuruteraan, tetamu-tetamu jemputan, para staf dan pelajar, serta hadirin sekalian. Selamat datang diucapkan ke majlis syarahan inaugural oleh yang berbahagia Profesor Insinyur Dr. Aduwati Sali. Bagi memberkati majlis syarahan pada pagi ini, dijemput Encik Muhammad Zulkhairi Zakaria bagi memimpin bacaan doa. Dipersilakan.
Assalamualaikum warahmatullahi wabarakatuh. Al-Fatihah. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin, arrahmanir rahim, maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Hamdan yuafi ni'amahu wa yukafi'u mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhika wa azim sultanik. Allahumma salli ala sayyidina Muhammadin salatan tunjina biha min jami'il ahwali wal afat wa taqdi lana biha min jami'il hajat wa tutahhiruna biha min jami'is sayyi'at wa tarfa'una biha 'indaka 'an darajat wa tuballighuna biha aqsal ghayati min jami'il khairati fil hayati wa ba'dal mamat wa ala alihi wa sahbihi wa barik wa sallim. Allahumma salli ala sayyidina Muhammad tibbil qulubi wa dawaiha wa afiyatil abdani wa shifaiha wa nuril absari wa diyaiha wa ala alihi wa sahbihi wa barik wa sallim. Ya Allah Al-Wajid, Ar-Rahman, Ar-Rahim, Al-Syakur. Sesungguhnya kami memanjatkan kesyukuran di atas segala nikmat dan rahmat yang telah Engkau kurniakan kepada kami, kedua ibu bapa kami, ahli keluarga kami, sahabat handai kami, guru-guru kami, serta seluruh warga Universiti Putra Malaysia. Ya Allah Al-Mu'izz, Kau berikanlah kami kekhusyukan di majlis yang berbahagia Inaugural Profesor IR Dr. Aduwati Sali pada hari ini, supaya kami tergolong dalam kumpulan yang Kau muliakan, serta Kau muliakan juga semua yang terlibat dalam menjayakan majlis ini, Ya Allah. Ya Allah Al-Fatad Al-Wadud, kami memohon kepadamu, Ya Allah, supaya majlis inaugural yang berbahagia Profesor IR Dr. Aduwati Sali ini, Kau berikanlah kelancaran, dimudahkan dan di akhirnya beroleh kejayaan. Ya Allah Al-Basit, Kau buka luaskanlah pintu-pintu ilmu-Mu, supaya dapat kami manfaatkan dalam ibadah pekerjaan kami. Sebahagian usaha kami meningkatkan kecermelangan diri serta Universiti Putra Malaysia dengan kuasa-Mu Al-Khalid. Ya Allah Al-Muqid, Kau bukakanlah jalan kejayaan serta kekuatan kepada kami dan generasi-generasi selepas kami untuk kami memartabatkan serta mencintai ilmu-Mu, Ya Allah. Ya Allah Al-Qudus, Kau sucikanlah serta Kau pelihara hati-hati kami sepanjang ibadah pekerjaan kami di Universiti Putra Malaysia dan hidup seharian kami bersama keluarga, sahabat handai dan guru-guru kami, supaya kami menjadi hamba yang Engkau redai. Ya Zal Jalali wal Ikram, tambahkanlah kepada kami kecintaan kepada segala kebaikan. Jadikanlah kami, guru-guru kami dan pemimpin-pemimpin kami terus berkhidmat dengan istiqamah untuk menabur bakti, membangun umat, masyarakat, bangsa dan agama. Ya Allah, Ya Tuhan kami, jadikanlah negara kami sebuah negara yang mendapat limpahan rahmat dan nikmat, kekalkanlah keamanan dan kemakmuran sepanjang zaman. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azaban nar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi ajma'in. Walhamdulillahi rabbil alamin.
Terima kasih diucapkan atas pimpinan bacaan doa sebentar tadi. Seterusnya, majlis menjemput Yang Berbahagia Datuk Profesor Dr. Ahmad Farhan Muhammad Sadullah, Naib Chancellor Universiti Putra Malaysia, untuk memperkenalkan Yang Berbahagia Profesor Insinyur Dr. Aduwati Sali, dan seterusnya menjemput Yang Berbahagia Profesor Insinyur Dr. Aduwati Sali untuk menyampaikan syarahan inaugural beliau. Dengan segala hormatnya, majlis mempersilakan.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahi rabbil alamin, wassalatu wassalamu ala ashrafil anbiya wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Terima kasih saudari pengurusi majlis yang berbahagia, Profesor Engineer Dr. Muhammad Khairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan Universiti Putra Malaysia, yang diraikan yang berbahagia Profesor Engineer Dr. Aduwati Sali yang akan menyampaikan syarahan inaugural pada pagi ini, ahli keluarga beliau yang disayangi dan yang menyayangi, ahli jawatankuasa pengurusan universiti, pegawai-pegawai kanan universiti, ahli pengurusan Fakulti Kejuruteraan, tetamu-tetamu jemputan, rakan industri, para staf dan pelajar dan sidang penonton yang dikasihi sekalian. Alhamdulillah, syukur kehadrat Allah Ta'ala kerana dengan limpah kurnianya kita masih lagi diberi peluang untuk bersama-sama bagi meneruskan usaha memartabatkan kesarjanaan ilmu pada pagi ini. Izinkan saya membaca latar belakang Profesor Engineer Dr. Aduwati Sali di dalam majlis yang gemilang ini. Aduwati Sali adalah anak keempat daripada 5 orang anak pasangan Sali bin Ibrahim dan Zainab Noh, dan beliau dilahirkan pada 31 Julai 1977 di Bayan Lepas, Pulau Pinang. Orang Pinang. Beliau bersekolah di SRK Seri Permai Bayan Lepas, Pulau Pinang, dan seterusnya ke Sekolah Tun Fatimah, Johor Bahru. Untuk pengajian tertiary, beliau berjaya mendapat beasiswa daripada Telekom Malaysia untuk melanjutkan pelajaran dalam bidang diploma kejuruteraan elektronik di Institut Teknologi Tinggi Malaysia di Taiping pada tahun 1995 hingga 1997, dan seterusnya ke peringkat ijazah di University of Edinburgh, United Kingdom pada tahun 1997 hingga 1999. Sekembalinya ke tanah air, beliau bekerja di Telekom Malaysia sebagai pembantu pengurus. Beliau menukar kerjaya kepada bidang akademik dengan menjadi tutor di Fakulti Kejuruteraan UPM dari tahun 2000. Kerjaya akademik ini membuka peluang kepada beliau melanjutkan pelajaran ke peringkat sarjana dalam bidang wireless komunikasi dan rangkaian di UPM pada tahun 2002. Sidang hadirin yang dimuliakan sekalian, seterusnya Aduwati dilantik sebagai pensyarah pada tahun 2003 sebelum menyambung pengajian di peringkat PhD di University of Surrey pada tahun 2004. Sepanjang pengajian PhD, beliau terlibat secara langsung dengan projek EU SETNEC 1 dan 2. Sekembalinya ke UPM, beliau telah dilantik sebagai pensyarah kanan di Jabatan Kejuruteraan Sistem Komputer dan Komunikasi Fakulti Kejuruteraan pada tahun 2009. Beliau memegang jawatan di peringkat jabatan sebagai penyelaras penyelidikan, pembangunan dan Master Kejuruteraan Komunikasi, Master of Science Kejurkhusus, Master Kejuruteraan Komunikasi. Pada tahun 2016, beliau telah dilantik sebagai Timbalan Pengarah Pusat Pengurusan Pendidikan di bawah Unit Pengurusan Ilmu dan Perancangan Strategik Penyelidikan. Hadirin hadirat yang dihormati sekalian, berentasi lebih 20 tahun dalam kerjaya, beliau telah menerima pelbagai pengiktirafan dan anugerah. Antaranya ialah Top Research Scientist Malaysia 2018. Pemenang Honorable Mention 2021 US ASEAN Prize for Women 2021 Study UK Alumni Award for Professional Achievement. Secara kumulatif, beliau telah menerima geran pendidikan bernilai kira-kira RM4 juta dari dalam dan luar negara dan telah menjalankan konsultansi bernilai hampir 2 juta ringgit dalam bidang perundingan profesional. Beliau telah menerima geran pendidikan antarabangsa daripada the Academy of Sciences for the Developing World, Joint Grant, TWAS Comstack Joint Grants, EU Horizon 2020 Research and Innovation Staff Exchange, EU Erasmus Plus Capacity Building for Higher Education, NICT Japan ASEAN IVO and Asia Pacific Telecommunity daripada Kerajaan Jepun. Sehingga ke hari ini, beliau telah menerbitkan lebih 136 artikel jurnal dan menerbitkan sebuah buku dan 2 bab dalam buku, serta menjadi pembentang persidangan dalam dan luar negara. Hasil pengalaman dan kepakaran 23 tahun dalam bidang komunikasi wireless dan satelit telah membawa Profesor ke tahap ini. Sidang hadirin dan hadirat yang dimuliakan, Aduwati juga merupakan seorang jurutera profesional yang berdaftar di bawah Lembaga Jurutera Malaysia dan The Royal Engineering Council of UK. Selain menjadi Fellow Akademi Sains Malaysia, beliau juga merupakan penilai dan ahli Task Force MYRA, penilai Majlis Akreditasi Kejuruteraan Malaysia, pengurusi National Science Challenge dan juga ahli Senat Universiti Putra Malaysia. Beliau turut aktif dalam penglibatan dengan pihak agensi kerajaan dan industri, antaranya untuk Suruhanjaya Komunikasi dan Multimedia, Kementerian Komunikasi dan Digital, Agensi Angkasa Negara, Kementerian Sains, Teknologi dan Inovasi, TSGN dan juga Loranet. Sidang hadirin yang dikasihi sekalian, sekarang marilah kita mendengar syarahan inaugural oleh Profesor Dr. Engineer Aduwati Sali bertajuk Sky High Communication Anytime, Anywhere. Dipersilakan.
Terima kasih Datuk BC. Assalamualaikum warahmatullahi wabarakatuh. Bishrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Terima kasih diucapkan kepada yang berbahagia Datuk VC, Datuk Prof Dr. Ahmad Farhan Muhammad Sadullah, Chancellor Universiti Putra Malaysia, dan yang berbahagia Dekan Prof IR Dr. Muhammad Khairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan Universiti Putra Malaysia. Yang saya kasihi dan sayangi ahli keluarga, Prof IR Dr. Hezrul Abdul Karim, suami saya, adik saya Muhammad Syahimi Sali, ibu dan ayah mentua Dr. Abdul Karim bin Sedam dan Puan Halizah, dan 2 orang anak menakan lah kalau kata orang Penang, Muhammad Faiz dan juga Nur Atikah. Saya mohon izin untuk menyampaikan syarahan dalam bahasa Inggeris, ya, yang berbahagia Datuk dan ahli majlis sekalian. Bismillahirrahmanirrahim. Tajuk projek ataupun syarahan ini adalah Sky High Communication Anytime, Anywhere. So if I can present the agenda for today's inaugural lecture is on wireless communication. Some of you may have thought that this is about communication, like verbal communication, but it's actually for wireless communication, like what we have from our mobile phone. So the agenda is on this as listed here. On the wireless communication itself and how we do research to make sure that as many users can be accommodated as possible, which I use as the more the merrier. And then the radiation exposure from wireless signals. Sometimes when we are using a mobile phone, we are concerned whether the impact of the radiation on our health. Yeah, especially in 5G these days. Previously in 2020, people were wondering if it can cause cancer, for example, if there is a chip that can monitor you from the wireless signals. And I will be also talking about Internet of Everything, yes, specifically Internet of Things or IoT. And then on the satellite part, eye in the sky, land mobile satellite communication, and a little bit on our investigation on MH370. So if I may start, on wireless communications, remember this YouTube video. It was way back in 2020, if I may play it.
Jadi kita terpaksa memanjat pokok ini sekiranya kita ingin mendapatkan internet connection yang kuat sepanjang exam berlangsung.
This was Viviana from Pita Sabah. And if you remember, she couldn't get access to the internet when the online learning was held at that time due to the pandemic. And she has to climb up a hill in her hometown to get access to the internet. So that is the main reason, one of the main reasons why we do this study. How we can make sure that everyone can get access to the internet coverage of wireless communications anytime and anywhere. So how can we make sure that you as a user, you paid for the service and you get the quality of service and quality of experience that you have paid, as well as you get the right service and make sure that it is still healthy and safe for you to use. So this is the legacy of mobile communications in Malaysia. If you can see, right from 1985 until 1995, and then now we have 5G. So it spans over a long duration. I remember when I did my PhD, it was still 3G then, in the year 2000, 2004. But now it's 5G. It has been deployed in Malaysia for more than 70% in terms of coverage in Malaysia. So here, as the wireless communication or generation evolved, the speed also increases. We have our students here. I know that they want the highest speed to download the video. Some of them is using Putra Blast to download all the slides for their teaching and learning experience, right? And some of them are using it for their video gaming. So we want to have it faster and faster and faster. And not only that, we want to make sure that everything is connected to the internet. We want to make sure that this room is monitored, for example, so that we can maintain the quality of the room, for example, the aircon or the lights and etc. So all this is an overlying needs on the use of the internet as well as wireless communications. That is on the terrestrial part. The work is also looking on the satellite communications part, especially in the area where the terrestrial network is not available. Like, for example, in the sea, if you are using maritime services, or aeronautical services. These days, when you're flying, for example, Qatar Airways, you can get access to Wi-Fi. So actually, the Wi-Fi is connected to the satellite communication as their backbone, satellite network. So you can still have access even if you are, 30,000 feet in the sky. So combining the two is actually what we are investigating in the team. So we are based in Wireless and Photonics Network Research of Excellence, WIPNET Research Center, right here in the faculty, and we are based in the tower block, just at the end of this faculty. So from this issue, from the terrestrial part, from the satellite part, we want to make sure that internet is available for everyone, anytime and anywhere again. So what do? I'm trying to get this as layman as possible because it can be very technical. So we are looking into both terrestrial and satellite communications. We have the legacy networks, and now we have 5G and beyond. We are investigating now on 6G, and we also have some legacy networks that it is still there. Wi-Fi, for example, it is still there. It will be here. And how we can extend it to Internet of Things, Internet of Vehicles, Internet of Everything. And the underlying part is what are the parameters that we need to have, we need to achieve, so that the users, from users' point of view, you can have the best experience, you can have the best service. And from telco point of view, imagine that you're working with one of the telecommunication company, you want to make sure that it is still cost efficient. You still serve or meet the expected quality of service from the users. So we are looking from both angles, from the user side as well as from the telco side. So what we did, these are the work of my students. So based on this, we want to make sure we can serve as many users as possible. The more, the merrier. And we don't want anyone to be left behind. You know what will happen when your mobile phone is not connected, for example. right? Like for example, if one day you don't have internet access, it happened to us, and you can see how inconvenient it is. Or for example, you have your mobile phone, but you left it at home, so you don't have the access to communicate, access to the internet. So we want to make sure that everyone is not left behind. So we try to make sure that the users are served. So we use one technique called NOMA, non-orthogonal multiple access. And how can we make sure that the thin air, you know, the bandwidth is like actually from thin air, but we manage to modulate it so that the air can carry your data from your mobile phone to another person's mobile phone, or from this sensor transmitted over the internet to the cloud, and you can access it in your dashboard or from your mobile phone again. So we use this technique, and we would like to thank the EU for this grant on Horizon 2020 entitled ATOM. And we have done quite a number of work. So this one is one of them on the use of NOMA for 5G. It was then in 2016. And then we want to make sure that, you know, sometimes when you are undergoing a tunnel, when you're driving, for example, in smart tunnel, you don't have access to the internet. Or sometimes when you are outside the coverage, you don't have access to the internet again. So we are looking into how we can improve this by taking into consideration your channel state information. We call it CSI. So not crime service investigation, it's channel state information. So this CSI means that what is the status of your phone? Are you having a good channel, a good CSI, or are you having a poor CSI? So from this feedback, we can make sure that we can provide you with the right service, with the right transmission rate. I'm so short that I don't think this can do me justice. Okay, I think that's better. So we have the idea of getting this information so that we can increase the accuracy of the service. Okay. So the next one, so that's from the user point of view. You have your CSI taken into consideration, your service is guaranteed, whatever you requested, you will get it on time, yeah? Considering all the delay, the propagation. Next, we want to look into the telco point of view, the system provider point of view. How can we make sure that this system is optimized? Since 2013, we were looking into energy efficient wireless communication. So our team, led by Prof. Bohan and Prof. Noor is here. So we're looking into what can we do to make sure that the system, especially the transmission from the base station, is consuming a lot of energy, a lot of power, and this is one of the underlying costs to operate a mobile network. And also, we want to make sure that your UE, your mobile phone, sometimes you notice that it is consuming a lot of energy. Just over a few hours in a day, you have to charge again, and then you have to charge again. So we are looking into a system on how we can optimize this. So we say that this is system optimization, considering adaptive transmission, optimal design parameters, whilst maintaining still the quality of service and the quality of experience as the users requested. So we do this, we look into several considerations, some adaptive parameters. So you can see that on the right-hand side, on your right-hand side, the analytical and simulation on how we can adjust the transmission power from the base station. Base station are the one that you see by the roadside, all those like Eiffel Tower, if you can say. Sometimes they camouflage it with artificial leaves. So those are the base stations. So we want to make sure the communication between the base station and your mobile phone is optimized, considering all these parameters. And again, we are looking into energy efficient transmission. When the energy is limited, so this is a big issue in wireless communication, we want to make sure that the base station is optimized, your UE is optimized, the transmission itself of the wireless signal is optimized. So we were suggesting the simultaneous wireless information and power transfer suite. One of our students just now, Tulasi, I think he's here, he was saying that how can we make sure that the energy is really optimized so that it will not consume much. Of course, energy, when we release it, it is also related to carbon emission. So we use suite, SWIPT, so that the energy can be harvested from the environment especially for the operation of the base station. So we look into this topic. Again, this is funded by the EU Horizon 2020 Atom project. We look into how we can transmit both wireless information like normal phone as well as wireless power, so that you don't have to charge your phone using the normal charger with the cable and etc. We want to charge it wirelessly. So it was a simulation related work. And then how we see this can be done using a relay. Relay means that you are far from the base station, so there will be another mini base station, so-called. So this is what we call as relay. Yeah, so we did simulation and we configure by the number of antenna in the base station. If you see the base station, there is a box, yeah, like a box, like a square. We have Huawei here. Thank you, Huawei, for coming over. So this base station, Huawei is one of the producer. So we can configure the antenna, number of antenna. We can configure the transmission power. So from all this, we can find the sweet spot of the optimized point. Yeah, if you can see here on the right again, the orange in color, the star is the sweet spot where everything is optimized. So you can see M equivalent to 148 means number of antenna, K equivalent to 29, number of users at any particular time, and then energy efficiency is the highest, which is 7.043 bit per second per hertz per watt. So this was what we investigated in Atom project. So if I can play a video to promote this project.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aduwati Sali from Wireless and Photonic Network Research Center of Excellence, WIPNET, Department of Computer and Communication Systems Engineering, Faculty of Engineering, UPM. So the team, which is the Wireless and Network Group, consists of several researchers from the department as well as postgraduate students, masters and PhD. We had our breakthrough in 2016 when we were awarded, together with other partners in Malaysia, in Asia, as well as in Europe, a project entitled Atom, Advancing the State of the Art of MIMO. So from this project, it stems collaboration between UPM, UTM, another university in Malaysia, which is also involved in this project, as well as European universities, specifically University of Lancaster, University of York in the UK, and University of Cyprus in Cyprus. So we had quite a number of secondments, we call it secondments, which is the research attachment with other universities' lab. So my students, my PhD students, and a few of our researchers, including myself, we went to all these 3 universities in Europe for collaboration, and we were attached with their labs. So for us to gain more experience in other people's labs, especially world-renowned labs. So from that Atom project, it stems several other local projects which we managed to obtain from University of Putra Malaysia. Universiti Putra Malaysia called Grand Putra, entitled IMOSEN, energy efficient MIMO for wireless networks, for 5G wireless networks. So basically this IMOSEN project, as well as another sub-project called NOMA MIMO, this has helped us with the collaboration with UPM, with universities in Europe. And from here, we managed to find solutions and investigation regarding 5G, fixed satellite service. So we explored all in terms of the transmission and optimization capabilities. So for example, a few of my students are working on NOMA, non-orthogonal multiple access. NOMA is used to increase capacity, and there are several other issues related to that. For example, fairness, throughput, data rate, delay, sum rate, and another one, a few other students are working on the energy efficiency for heterogeneous networks. And some of my students are also working on SWIT, simultaneous wireless information and power transfer. So in the future, we have, for example, our mobile phone receive wireless signals as well as wireless power transfer. So a few of the students are also working on that. On top of that, we're also working in satellite services. So some of us are working on DVB-S2X, that is a new standard for satellite networks. And also we are investigating future 5G or beyond 5G networks, where wireless networks is integrated with satellite. We have machine learning for optimization. We have IoT integrated in the network. So all these transmission issues, heterogeneous networks issues, we are investigating in this wireless and network lab.
My name is Intan. I'm from Cyberview Sdn Bhd under the Managing Director's Office. So this is our first 5G Open Lab in Malaysia. This is a collaboration between Cyberview Sdn Bhd and also DG Telecommunications. We also have other partners like ZTE as our equipment provider, and also the use cases partners. One of it is our very own Universiti Putra Malaysia. So this 5G Open Lab is opened since 1st October 2019, and we are looking at use cases from 4 critical areas. That's the smart mobility, smart healthcare, digital cycle of use cases assessment. So we have around 23 use cases that has been registered in this lab. So we will be still open for application from universities, from companies, startups, and also individuals to test their equipments, applications, or devices using 5G network and technology.
UPM has been lucky enough to be collaborating with Recascape Cyberview, DG and ZTE to conduct one of the selected use cases for 5G since 2019. So we have completed one use case on 5G and fixed satellite service indoor communications, and we hope to extend this to the next step, which is on the outdoor measurement for 5G. So there are 2 frequencies that will be involved. One C-band for indoor, and then for outdoor we're going to use multimeter wave frequency. So from this collaboration between academia, industry, government agencies, it will spur more collaborations and more quality for research, because we are taking into consideration the end users' needs and expectations. So for example, we want to make sure that 5G will be deployed successfully in Malaysia through these use cases, and we can make sure that these use cases can be deployed or executed in other parts of Malaysia. So from here we can develop some standards for 5G and other related services for Malaysian scenario.
Okay, so that was the project that we had with the EU in collaboration with Cyberview and other industry players. So next, we are looking into what is the radiation exposure on our health from all these wireless signals. So although it is a non-ionizing signal, what we have from wireless signals, so it's not like when you have radiotherapy or when you have X-ray. So it's not ionizing. Those are ionizing signals, but non-ionizing is there any effect on our body? So this is what we investigated next on radiation exposure from wireless signals. So based on this frequency, we transmit wireless information using frequency. Like for example, Wi-Fi is operated at 2.4 gigahertz. 5G is operating at 3.4 gigahertz, for example, in Malaysia. And then satellite, for example, also 3.7 gigahertz, and some other frequencies at Ku and Ka band. So different frequencies is meant for different kind of services. So we want to know, specifically, we were investigating on C-band and millimeter wave from 5G signals. Is there any effect on our health? So what we did is we conduct measurement. Again, this one, thank you to our students. We have Ashley and Benny here. So those are my PhD students anyway. So we conducted this radiation exposure at Cyberview, again, one of our collaborators. So this was at millimeter wave, and we conducted the measurement campaign day and night, if you can see. during the day and during the night. So we see how is the exposure light. We have our threshold, which is from ICNIP. ICNIP is endorsed by WHO, World Health Organization. Like for example, it's 61 volt per meter, the maximum. So we want to make sure, is it what we are exposing ourselves less than that, or is it higher than that? So we behave like an independent body to investigate on this, and we tested on several scenarios, like how much is the exposure when you are downloading YouTube? How much is the exposure when you are just scrolling your WhatsApp, for example? So we have that results, yeah, you can find it in our papers, but the take-home message is when you are surfing your YouTube, the exposure is higher compared to when you're using WhatsApp. And especially higher when you are playing video games, especially for the students. So you're exposing radiation more and more to yourself. It's not immediate, but over a long time, there is still no study for a longer time, but just be diligent when using your mobile phone. Yeah, especially to my students. So we did that measurement campaign, and then from that measurement we had data. So we do machine learning to do prediction and modeling of this signal. So what we did is we used these machine learning techniques, and we formulate which one is the best prediction model, so that we can say that when you use this formulation, machine learning formulation, that it is similar to what you will be exposing to yourself. So you can see on the top right, so the exposure is not as high yet. Yeah? The red ones are the threshold by ICNIP, and the bottom ones are the exposure, the real exposure that we have measured. Okay, so that's on the radiation. It is still ongoing. We have several measurement campaign completed this year. And the next one is Internet of Everything, IoE. Yeah? The existing manual peatland monitoring. Can we help with the technology? So we know because IoT, we can deploy sensors and we can just leave it there. Yeah? And then you can just view the data from your mobile phone as long as you have, you know, again, access to the internet, you have your mobile phone or your laptop or your PC, then you can view it in your dashboard. So we did that. We deployed the IoT system in Hutan Simpan Raja Musa in Malaysia. It has the ground sensors in the peatland, and we also have the weather sensors, weather-related data. So we monitored the peatland soil. The peatland soil is not the same as the normal tropical forest soil. It has several layers of soil, clay layer, peat layer, top layer, and then we monitor the groundwater level, the soil humidity, the soil temperature, and we replicate the system in 3 ASEAN countries. Number 1 is in Jambi, Indonesia, in Sumatra Barat, and then in Malaysia itself, in Hutan Simpan Raja Musa, and in Badas, Brunei. So although the system is the same, replicated in 3 countries, but the local issues is addressed by each individual collaborator. Okay, so from there we investigate how we can make sure that the transmission happen even in the forest when there is no internet is intermittent. So we use LoRa technology. LoRa is one wireless access that is free to use. Thanks to MCMC for regulating this. As long as we transmit at regulated frequency, 917 megahertz to 923 megahertz, below than 0.5 watt, you can transmit anywhere and anytime, as long as you don't interfere with other services. So we did that. We deployed LoRa in Hutan Simpan Raja Musa, as well as in the other 2 peatland forests, in Badas, as well as in Jambi. So it was successful, alhamdulillah. So from the ground sensors, we send to the LoRa gateway using LoRa, and then from LoRa gateway, we can have access to the internet using 4G. And then when we deployed it over a longer duration, we deployed it since 2020. So we have quite a reasonable amount of data. So we do big data analytics. Dr. Nordin, thank you, Dr. Nordin, for coming. Dr. Nordin is from MIMOS, and he is one of the collaborators here in this project. Just in time, Doctor. So we do analytics from groundwater level. So the piezometer that we deploy in the peatland forest, we analyze it and we do prediction with machine learning. So again, we do prediction and we model it according to what the local community is using it, because we want to make sure the local community will benefit from this technology. So we use the fire risk code. If you see on the right, the red, yellow, green, and blue, we use the same threshold and we model it using machine learning. And then after that, when we see that, okay, we have the data, it is stable now, this IoT system is working, we can verify it. We say that why not we integrate it with another system. So we chose Fire Danger Rating System, FDRS, which is regulated and owned by Meteorological Department, Met Malaysia. So we know that FDRS has been using remote sensing data. So we say that, okay, Met Malaysia, is it okay if we try to investigate, can we correlate the data that we have from the IoT system on the ground with your system, FDRS system that you have from the remote sensing data, from the satellite data? So we did that, and then we tried to model the fire weather index, FWI indices. Yeah, so those are the indices. First, we model groundwater level to formulate drought code. So the higher the drought code means that the higher the potential of drought, and the higher the potential of peatland forest fire. And then the next index, is we model the DAF moisture code. What is the moisture of that particular soil, peatland soil in that area? And then finally, we look into the fire weather index itself. So we use machine learning again. We've been working machine learning quite extensively in our work, and we try to jumble up 4 input compared to 9 inputs. Of course, there are issues regarding complexity, accuracy, and we notice that the best or the sweet spot, the optimized version that we have is this particular 9 input, 5-layer model, and a robust and reliable tool for fire weather index prediction. So this is what we did in this project. And then we have developed this dashboard with the help of Dr. Nordin from IMOS just now, as well as from LoRaNet. I'm not sure whether Shamli is here today. So we developed this peatland dashboard so that the local community, especially the peatland forest ranger, they call it forest ranger by Jabatan Perhutanan Negeri Selangor Forest Department, can use it. And then our student developed this, enhanced this dashboard as well regarding the prediction that I mentioned just now. So if I may play the video of this project. Saya Aduwati dari WIPNET Fakulti Kejuruteraan UPM. ITIS dibayai oleh Universiti Jepun dan kolaborasi antara UPM, MIMOS di Malaysia dan juga IPB, Universiti Pertanian Bogor dan BPPT di Indonesia, dan di Brunei kita ada UTB, Universiti Teknologi Brunei. So 3 negara, Malaysia, Brunei dan Indonesia, kami akan melaksanakan IoT based peatland monitoring, ya, untuk memantau paya gambut di negara kami. So di Malaysia kita telah mengenal pasti hutan simpan ataupun hutan paya gambut di Raja Musa ni di Kuala Selangor untuk kita pasang IoT sistem supaya kita dapat pantau kedalaman air di dalam tanah paya gambut. So di atas ni kita ada weather station, ya, stesen cuaca dan juga alat-alat LoRa untuk transmission ataupun penghantaran isyarat daripada seaway dan juga weather station, dan kita hantar ke cloud
Di cloud itu kita akan push kepada control center. So control center akan berada di UPM ataupun di MIMOS. Dan ada juga cloud server yang kita parkkan kepada NICT Jepun. So ada beberapa tempat yang kita storekan data ini, dan data yang diterima kita gunakan untuk ramalan kepada kebakaran hutan. Kebakaran hutan ini kalau dari segi skala besar akan menyebabkan jerbu. Dan macam yang kita tahu pada tahun 2019 jerbu yang teruk berlaku di Malaysia, bukan saja di Malaysia tapi juga di Indonesia dan Brunei. So kita diharapkan dapat daripada IoT sistem ini akan dapat mengawal dan juga mengawasi hutan paya gambut daripada kebakaran.
Saya akan explain main components of our system ni. So dekat sini kita ada dua sistem, dua item. Yang pertama ini kita panggil sebagai weather station lah. So fungsi weather station ni dia akan mengambil data berkenaan hujan, temperature, humidity dan wind direction, dan ada beberapa akan memberi maksud berkenaan keadaan semasa cuaca di kawasan ni. Dan dari data ni kita boleh buat analisis dan predict lah sama ada akan berlaku kebakaran, risiko kebakaran itu tinggi dan sebagainya. Dan ini pula adalah dipanggil LoRa Gateway. So LoRa Gateway ni apa fungsi dia adalah dia akan mengumpul data-data daripada sensor yang kita pasang di bawah. Dan sensor ni kelebihan dia kita boleh pasang sensor sehingga 5 km. So di kawasan yang tak ada mobile coverage kita boleh pasang, dan dia akan capture data dan kita akan hantar ke cloud lah. Dan ni adalah antena dia. Kalau kita tengok bahagian atas ni, so antena ni boleh cover up to 5 km.
Our role in this project actually is developing the platform. We have developed the platform by using MIMOS MyMIS platform, and from there we process data and to display to be used for the managing this forest reserve. At the meantime, also we provide the alert whenever system trigger any anomaly or something wrong, to be sent directly to dashboard as well as to the end user mobile phones.
Dulu pemantauan yang dijalankan di kawasan hutan Simpang Raja Musa ni, kita melakukan pemantauan kebakaran ini dengan mengadakan rondaan di kawasan-kawasan ini, dan juga kita juga membuat pemantauan menggunakan piezometer secara manual di sini. Sekarang ni kita di kawasan Raja Musa ni telah menggunakan sistem yang telah dibangunkan oleh UPM dan MIMOS. Apa yang kita dapati bahawa dengan menggunakan sistem ini memberi maklumat secara terus kepada pengguna lah, pada pengguna, dan ia memberikan amaran dan juga tindakan yang lebih awal untuk kita mengawal kebakaran. Jadi sistem ini sangat berguna, sangat mempercepatkan dan mempermudahkan pemantauan dan juga pengawalan kebakaran.
Terima kasih diucap. Thank you to the funding body, which is NICT Japan, as well as Asia Pacific Telecommunity under the government of Japan. So next is on satellite, eye in the sky. So where the areas which are remote and couldn't be accessed using the legacy terrestrial network, we have to use the satellite communications, right, in the maritime or aeronautical or in remote areas in Sabah and Sarawak. So we are looking into the issues regarding interference, especially when the frequency that is used next to each other. For example, in 5G, in C-band, it is operating at 3.4 until 3.6 gigahertz, for example. And then the fixed satellite service is using at 3.7 until 4.2 gigahertz. So when they are next to each other, there is bound to be interfering with each other. So we want to make sure that the coexistence is maintained, and we have made measurement campaign again on how we can see or what is the value of interference between 5G at C-band and the fixed satellite service, also in C-band. So if you can see the plots there, the satellite signal and the 5G signal, which is really close to each other. So we want to make sure that it is not interfering, and we conducted measurement in MAEPS. This was in 2020, and MAEPS was the health center for the COVID patients, the case 1 and 2 then in 2020. So we conducted the measurement there because 5G was first deployed there for the use of health providers in MAEPS. So we see how we can do filtering so that this 5G and satellite service will not interfere at this frequency band. And then we use, again, machine learning to model this interference. And we have shown that how this machine learning can formulate and model the interference between the two services. Okay. So when we talk about satellite, these issues on rain. Previously, if you remember way back, probably 5 to 6 years ago, when you are watching a satellite TV, sometimes when it's raining, it just goes black, right? So the main issue there is attenuation due to rain. Because frequency at that transmission is really high, it can be diffracted by the amount of rain, especially us in tropical region. So if you have been to Europe, for example, temperate region, the rain there, the size of the rain is not similar to the size of the rain here in Malaysia, right? So the intensity, rain intensity is different, and tropical region, we suffered more than the temperate region from this rain attenuation. Yeah, so don't blame the satellite service provider. It's the nature of the wireless signal. So we investigated from that angle, and we have compared the rain attenuation in Penang, which is a tropical region, and Athens, which is a temperate region. So we see that the rain attenuation in tropical region is so much higher. If you can see on the left-hand side, the huge difference between the two. So we provided an adaptive technique called adaptive modulation and coding, or ACM, adaptive coding and modulation. Yeah, and then we have tested this on DVB S2X, which is one of the newest access technology for satellite communications. And we have shown that although it is raining, although it is attenuated, although your view is just black, we can still transmit the signal, and the user can still see some moving football players, for example, if you're watching EPL or any football match over satellite TV. So you can still see the players running, chasing the ball. Yeah, but not the minute detail, not the pixel is probably compromised, but you can still see the ball, you can still see the player, so it's good enough, right? So this is what we do, and we call it as ACM, adaptive coding and modulation. So again, on the satellite, we consider that issue as static, fixed, or we call it fixed satellite service. But we also investigated LMS, land mobile satellite. So it means that when our satellite antenna is moving, so the first case is we tested it on a car, and this is a collaboration with UKM, with Prof Mandip in UKM. So we put the satellite antenna on top of a car, if you can see there, and we drove around and then test the effect of tunnels, the effect of rain, and that is rain gauge, if you can see, rain gauge, and then mobile antenna, and then we model it using this technique called how we can model the cloud impairment, the rain impairment, the tropospheric scintillation. So when we talk about satellite, it's high up, especially geosatellite, 36,000 kilometers, and a lot of things can happen between that 36,000 kilometers and us on the ground. So we model it, and we make sure that mobility model is included. So that is a novelty because we use land mobile satellite. And then, Alhamdulillah, the modeling is good. Yeah. So anyone who wants to model a land mobile satellite can use the same model that we have developed here, and we have published in a high impact journal. So that is on the car, and then we tested as well on a high-speed train, and this is ETS. So we tested, we collaborated with ETS, yeah, KTM, and we put the satellite antenna on top of the train, and we model it. And you know what is the main issue in the train? Is the power arch, because it is an electric powered train. So the power arch, which is around every 100 meter, you will see it because it provides the electricity, the power to the train, right? So this power arch can diffract the satellite signal. So, for example, if you're watching a YouTube video, it will flicker every few seconds or so because of this power arch. So we model it considering the power arch, and we considered the other obstacles like trees, buildings, bridges, and tunnels. Okay, so that's on the train. Then you can see all this attenuation. If you can see here, the right-hand side, where the attenuation, the highest happen when you are undergoing through a tunnel, when you are in the train, yeah, compared to the bridge, high-rise building, trees, and clear sky. Clear sky means there is no obstacle. You can get directly from the satellite. Okay. So we have also looked into satellite on the car, satellite on the train, and then we look how can we propose an internet solution when you are in the train cabin. So we were proposing satellite meets Li-Fi. Li-Fi is like Wi-Fi, but this is light fidelity. So what if we can have Li-Fi when you are in the cabin? You are a passenger, and you can have high-speed internet using Wi-Fi, and the backbone is satellite communication. So this is especially for areas where you don't have access to 4G or LTE or 5G, in that matter. So this is my PhD student's work, Kalai, Dr. Kalai. I think he's viewing from FB live streaming. So he modeled this using Li-Fi access point, and we have conducted some measurements, so it is feasible, but of course more investigation has to be done, especially for Li-Fi. Vibration is an issue. When the cabin is vibrating, yeah, of course when you are running on a track, then is it gonna affect the transmission level? So we are working on that now, inshallah. So the last one, also on satellite and also on the last topic of this lecture, MH370. I am lucky to have Prof. Aliani here. He's there. And also, she is our birthday girl today. Happy birthday, Prof. Aliani. So we were investigating on MH370, and specifically on the pings. If you remember, it was 9 years ago in 2014. The pings emitted from the satellite, yeah, the service provider was Inmarsat, which is based in the UK. And this fateful day, the flight, it is communicating every 1 hour or so with the Inmarsat satellite, because we couldn't find any other communication with the flight, right, as we know it today. So after they have found out, okay, there is one communication, albeit every 1 hour or so, from the satellite to the flight. So we were being asked, especially by the media, on can we try to decipher this and then try to convey this to the public so that the public can know, especially Malaysian public. And then myself and Prof. Aliani, we were trying our best to try explain this to the public. And then, if you remember, there was burst frequency offset and burst time offset, and we tried to correlate that with our own methodology. So we have this data log, we call it, from Inmarsat. Inmarsat is kind enough to release it to the public. And then I was doing PhD in University of Surrey, and I used Inmarsat service as my project, as the base of my project, because I was proposing satellite communication for maritime using this BGAN-X, one of Inmarsat service. So I said that, oh, this looks familiar. This data log I've been studying for my PhD. So I said that, okay, I know how it looks like. I know what it means, P channel, C channel, T channel, and then Prof. Alani is the expert in microwave engineering. So we were working together on this, and then we proposed an alternative to correlate, to verify the investigation that has been done by the investigators in this investigation bureau. So we try to use the received signal rather than just BFO and BTO. So it is like, for example, when you hear an ambulance coming, the further there are, the lower the sound, right? You hear it weak and weaker and weaker and weaker. When it is closer to you, you hear it loudly. Right? So this is how received signal works as well. So the closer you are to the source of the signal, is the higher the signal. Or maybe I should give an example of Wi-Fi. Yeah, okay, maybe easier. So your Wi-Fi, you have the bars, right? 4 bar, 3 bar, 2 bar, 1 bar. So the closer you are to the access point, the more bars you have, isn't it? So that's how received signal works. So we do that and we correlate and we plot the dots, and then it happens to be also in South Indian Ocean. But as we know it, even today after 9 years, it is still far from being found. So we hope to get access to more data or more aspects of study that we can study, we can investigate on, and hopefully, we can have some leads to this issue. Okay, so we still don't know where is this flight. Where is MH370? It is still a big question. Even next year is the 10th year of the missing flight. So that concludes my talk. Yeah. So we have investigated from mobile point of view, wireless communications, 5G, IoT, and the satellite as well, DVB-S2X, and we see that in the future, satellite and IoT will take a lead role, especially in 6G networks. Yeah, so that's on satellite and IoT, and the needs for more environmental management and monitoring, because the Earth is sick, right? People are burning the forests, and the climate change is upon us right now. And we also look into the issue of transboundary haze alert. We get good recommendation from the international body, yeah, especially funding body on transboundary haze alert, but we really hope that the local government, our own government, can also play a big role in giving funding for researchers to do these transboundary haze related topics. And now that 6G is looking into higher and higher frequency. Just now we have C-band, 3.4 gigahertz. We have millimeter wave, around 29 gigahertz. But for 6G, we are looking into terahertz, which is even higher frequency. So we want to see whether the radiation exposure, is it going to be the same or is it going to be higher? So that's on the radiation exposure from 5G frequency bands. And we also want to look into massive MIMO now, as we have more and more devices. Each of us probably have more than one mobile phone. So each mobile phone will be connected to the base station. So we want to make sure the antenna is using massive MIMO so that we can serve more users. And probably we can explore again on millimeter wave and terahertz. So I think that is all on the inaugural lecture. If I can take this opportunity for us to recite Al-Fatiha to my parents, Allah Yarham Sali Ibrahim and Allah Yarhamah Zainab, no? I'll be very happy. So Al-Fatiha. I'm sure they will be very proud for today's event. So I would like to dedicate as well to my family, Prof. Engineer Dr. Hazrul Abdul Karim here. He's a professor at Multimedia University Cyberjaya. My children, I have 4 boys, Hazim, Abdul Hasib, Abdul Haq, and Abdul Hai. And I would like to thank special dedication to my awesome and incredible mentors, Prof. Noor Kamariah Nordin and Prof. Borhan. I'm not sure Prof. Borhan is here or not. Oh, okay, he's here. Okay, salam, Prof. And then especially to my Department of Computer and Communication Systems Engineering, the faculty, thank you, Prof. Dekan, WIPNET Research Center, Academy of Sciences Malaysia, Young Scientist Network, IEEE Malaysia ComVT. Yeah, and also to my sisters. I have three sisters, so myself, the fourth one, and I have my younger brother here, Muhammad Syahimi Sali. He's our pride of the family. Alhamdulillah, he's a geologist at Petronas. And to my in-laws, thank you, Papa and Mama, Dr. Abdul Karim and Puan Haliza. My sister-in-laws, Dr. Azila and Faizal, family. Amalina and Mizi, yeah, and Anati and Mahfuz and family. And also I would like to acknowledge everyone in the Department of Computer and Communication Systems Engineering. I must say that probably it is the best department in the faculty. Right, okay, thank you. So I'm sure they are all here. And special acknowledgement to my students. We have our current postgraduate, thank you. I see quite a number of you are here, and those who have graduated, I hope you can view it online over our Facebook live stream. And then I am lucky, and thank you to the department for appointing me as our master taught courses in Master in Communication Engineering. So we had a great time having lunch in IOI, taking measurement in KL Central and Cyberview and etc. And having lunch again in Dewan in Bangi. And also thank you to my undergraduate students. I can see that our alumni are here, thank you. I can see Arif. Yeah, and Koyum, thank you for coming, and also the others who are still here. So these are my final year project students. And I think I have a great time, and I see them grow from you know, students first year, second year, third year, and final year when they are more mature, and then they engage with the industry, and they come back to serve. They come back, and then say hi to me. I think that is the best thing for any lecturer, for any teacher in the world. When you see that your students are growing to be a mature, a gentleman, a lady, and come back and serve the community. So thank you. I think we can enjoy the video, a tribute to everyone who has helped me. Okay, over to you. Thank you. Please enjoy.
Aduwati Sali.
Saya Aduwati.
Saya Aduwati Sali from Wireless and Photonic Network Research Center of Excellence, WIPNET.
Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi. Mari kita beri tepukan kepada yang diraikan. Ini kali pertama saya ingin gulung. I will not give another lecture. Pertamanya saya ucapkan tahniah dan terima kasih atas perkongsian hasil penyelidikan yang menyeluruh. Tahniah kepada Prof dan juga kepada rakan-rakan yang saya lihat pilihan problem statementnya amat berimpak tinggi dan menyelesaikan masalah-masalah yang memang diperlukan oleh negara dan dunia. Dan salah satu soalan yang saya tanya dalam interaksi saya bersama dekan-dekan dan pengarah adalah isu jerubu. Bagaimana sektor agriculture, sektor pertanian sebenarnya menjadi penyebab transnational jerubu. Dan of course I got answers, tetapi Prof dan rakan-rakan memberikan juga solution. Dan itu adalah satu hasil penyelidikan yang berimpak tinggi yang saya harap tidak hanya terkubur di penerbitan sahaja, tetapi dibawa kepada pentas yang lebih jauh walaupun cabarannya banyak untuk membawa kepada peringkat yang seterusnya, tetapi saya yakin kalau kita bijak menggunakan pelbagai medium dan pelbagai kaedah, insyaAllah one day all our research results will actually be used through the industry towards solving the problems of humanity. Dan saya nampak secara jelas Prof telah melihat kepada isu accessibility, dan itu juga akan membantu inclusivity of solution and technology adoption towards enhancing the agriculture industry. Jadi the complexity of the work need to be converted into the simplicity of utilization and the right economic scale. So ayuh kita sama-sama di UPM melanjutkan semua usaha yang kita telah lakukan, penyelidikannya yang dijalankan dalam penggunaan sebenar. Dan ini merupakan satu perkara yang diperlukan, kerana tanpa itu UPM akan sentiasa dinyatakan sebagai tidak mendukung usaha yang diperlukan untuk keperluan pertanian dan juga perkara-perkara berkaitan seperti keterjaminan dan makanan dan sebagainya. Kerana persepsi masyarakat itu kadang-kadang tidak boleh dikawal. Jadi kita kena bijak untuk menangani persepsi itu, dan saya yakin Prof kita hari ini dan rakan-rakan beliau dan seluruh anggota Fakulti Kejuruteraan dan juga UPM perlu berupaya untuk melakukan itu. Mungkin itu kesimpulan saya dari aspek liputan yang telah diberikan oleh Profesor, dan saya yakin insya-Allah Profesor masih muda. I've told you do not pause here. It is a shifting gear point, and hopefully you get more encouragement and more success beyond just research work, postgraduate and publication, and we hope that will provide impact that we need. Saya sama-samalah kita mendoakan agar usaha ini mendapat berkat rahmat dan berkat Allah Subhanahu Wa Taala di hari yang mulia ini, dan sama-samalah kita berdoa agar usaha sebegini akan diteruskan oleh pasukan Prof, dan sikit ringkasan daripada saya. Wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Majlis merakamkan jutaan terima kasih kepada Yang Berbahagia Datuk Naib Chancellor. Mohon Yang Berbahagia Datuk untuk terus kekal di atas pentas bagi sesi berikutnya. Majlis menjemput Yang Berbahagia Profesor Insinyur Dr. Muhammad Hairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan, untuk naik ke atas pentas bagi mengiringi Yang Berbahagia Naib Chancellor untuk menyampaikan cenderamata kepada Yang Berbahagia Profesor Insinyur Dr. Aduwati Sali sebagai tanda penghargaan. Dipersilakan. Majlis merakamkan ucapan terima kasih di atas sesi penyampaian cenderamata sebentar tadi. Dimohon Yang Berbahagia Datuk, Yang Berbahagia Dekan dan Profesor Aduwati untuk terus berada di atas pentas untuk sesi bergambar. Dijemput Ahli Pengurusan Fakulti Kejuruteraan untuk naik ke atas pentas bagi sesi bergambar. Dipersilakan. Majlis merakamkan ucapan terima kasih kepada ahli Seterusnya, majlis menjemput Profesor Insinyur Dr. Hezrul Abdul Karim, pasangan kepada yang berbahagia Profesor Insinyur Dr. Aduwati Sali serta ahli keluarga untuk menghadiahkan sejabak bunga dan seterusnya bergambar di atas pentas. Majlis merakamkan ucapan terima kasih kepada yang berbahagia Profesor Insinyur Dr. Aduwati Sali dan ahli keluarga untuk sesi bergambar sebentar tadi. Sekali lagi terima kasih diucapkan kepada yang berbahagia Profesor Insinyur Dr. Aduwati Sali dan ahli keluarga untuk sesi bergambar sebentar tadi. Hadirin sekalian, dengan berakhirnya sesi bergambar sebentar tadi, maka berakhirlah majlis syarahan inaugural pada pagi ini. Di kesempatan ini, majlis merakamkan ucapan tahniah dan syabas kepada yang berbahagia Profesor Insinyur Dr. Aduwati Sali yang para hadirin dijemput bagi menikmati jamuan makan tengah hari yang telah disediakan di luar perkarangan auditorium ini. Okey, kita akan teruskan kepada sesi yang bergambar sekali lagi. Mohon semua untuk ke tengah dewan untuk sesi bergambar beramai-ramai. Mohon hadirin yang berada di belakang untuk penuhkan ruangan hadapan untuk sesi bergambar beramai-ramai. Sekian sahaja majlis syarahan inaugural pada hari ini. Saya sudahi majlis dengan wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.